Okay, now before we wrap up our discussion of protocols and ports, let's talk about SAN or Storage Area Network protocols, and there's a few that we need to be aware of. First off, Fiber Channel is the predominant protocol for storage area networks. Okay, it's Fiber Channel or FCP, Fiber Channel Protocol. And what it does is it transports SCSI commands over Fiber Channel networks. Okay, SCSI stands for Small Computer Systems Interface. And Fiber Channel networks can run at one of several speeds, 2, 4, 8, or 16 gigabits per second. Typically, most environments are going to be running either 4 or 8, although you may see some of the newer installations running 16 gigabit per second. And to kind of make an analogy between a SAN network or a SAN device and also on an IP network or a LAN, we have the concept on a LAN, you have a server that has a NIC, a network interface card. That NIC will connect it obviously to an IP-based network. Well, servers can also have something called an HBA or a host bus adapter, and that host bus adapter is very similar to a NIC, but it's used for storage area networks. So instead of having a MAC address like a network adapter card would have, an HBA has what's called a WWN or a worldwide name. So it's similar to a MAC address in that it's unique. However, WWNs are comprised of two kind of subcomponents. We have a port WWN, which is unique per port, and then a node WWN, which is shared by some or all ports on a device. All right, because some HBAs are dual port. So it just depends upon your implementation. Okay, now the other thing with SAN that's a little bit different than what we have on the LAN side of the house is Fiber Channel uses switches, but they're a little bit different than the IP-based switches. Switches come in either a switch, which is kind of a fixed configuration, in other words, has a fixed port count, or it can come in kind of a semi-modular approach where it can accept line cards. Okay, so this would be an example of a semi-modular switch, a Cisco MDS 95 or 9250i. Okay, it's a SAN switch that would typically be used in the edge of your network. And then we have directors, which are modular with a high port count and high availability. So in this case, you have a Cisco MDS 9710. So this has line cards that can be pulled in and pulled out. Here you see it's fully populated, but you could start off with maybe just one line card, and then you could add additional line cards to give you more capacity as you grow. All right, but everything is highly available, redundant, redundant power supplies, redundant memory, the line cards themselves. Like I said, everything is set up for a very highly available environment. So typically, the directories will be set where you need a high port count, but they're going to be set up typically as like the core of your SAN infrastructure. And then, so all your storage arrays would connect to the core, and then your core would connect to the edge, and then all your hosts would then connect to the edge. So you have that kind of a core edge design. Okay, so just to give you an idea of what a storage array would look like, okay, here we have an example of one that is an 8-bay storage array comprised of thousands of disks. It has multiple engines, and you see on the end we have one of the cabinets that are open to show you just that there are engines behind that, or basically processors, and then DAEs or drive array enclosures that give you, hundreds or thousands of disks spread out across that array. Next, we have two other SAN protocols that I want you to be aware of. One is iSCSI, and one is FCOE. iSCSI basically enables you to have SCSI commands sent over an IP network. So iSCSI sits on top of TCP/IP. It is routable, but it's an alternative to Fiber Channel. Fiber Channel networks are very costly to implement. If it's not already in place, it's a pretty costly undertaking to build out a Fiber Channel network. So a lot of newer installations, and a lot of newer enterprises rather, opt for either iSCSI or FCOE. Between the two, iSCSI is routable, FCOE is not. So if you have a choice between the two, you have to take those things into consideration. But iSCSI really should have dedicated subnets or VLANs to avoid resource contention, because you have your SAN traffic competing with your IP traffic. So if you separate those out either via subnet or by VLAN, then you avoid that resource contention. FCOE, again an alternative to Fiber Channel, runs on top of Ethernet in the protocol stack. So it doesn't sit up quite as high, whereas iSCSI sits on top of TCP/IP, FCOE sits directly above on the Ethernet layer. So basically, it's not routable, in a nutshell. But here's an example of what an FCOE network would look like. Here you see we have two servers, we have some switches in place, and then of course it's attached to our storage area networks or our shared storage. Okay, so as we wrap up, let's go ahead and just make sure that we understand the well-known ports. Okay, again, these are ones that are by default. We've covered all of these except for the very last one, which I'll touch on briefly. But we know the well-known ports: 21 for FTP, 22 for SSH, Secure Copy, and SFTP. 25 is for Simple Mail Transport Protocol. Port 53 for DNS, port 80 for HTTP, port 110 for POP3 or for mail, basically when we pull mail down from a mail server. Port 139, actually 137, 138, and 139 for NetBIOS. Port 143 is for IMAP, and again, that's another type of mail protocol where we can pull mail from a server. Then we have port 443 for HTTPS, or HTTP Secure, and that uses TLS or SSL in the background. And then 3389 is Microsoft's port for Remote Desktop Protocol, or RDP, allowing you to remotely access or log into a server or a desktop as if you were sitting at the actual terminal. Okay, and last but not least, here are the ports, or the protocols rather, that we need to make sure we understand. So please go back through these, make sure you understand these for the exam. And from a security perspective, we need to understand which of these protocols are secure and which ones are not. In other words, which ones will pass information in the clear text unencrypted and which ones are in fact encrypted. And then we need to make sure we either disable or block insecure protocols if at all possible. Now, in some instances, there's just not an opportunity to do that. We just can't for whatever reason. But if we understand at least that they are insecure, we can mitigate the risk as much as possible. And then last but not least, use encryption whenever possible, especially over insecure networks, i.e. the internet. So I hope this module was informative for you. I'd like to thank you very much for watching.